This is our Group 6 Wi-Fi 6 report presentation. And the theme is the technological innovations and the social economic impact of the Wi-Fi 6 technology. The group member of the Group 6 is the Wei Chenhao and Zhong Yi. This is our directory, this page. We have 5 parts. The first part is the introduction. The second part is the technological innovations of the Wi-Fi 6. It have the physical layers and the MAC layers. And the third part is the social economic impact of the Wi-Fi 6. It have the industrial applications and the environmental and economic benefits of the Wi-Fi 6. The fourth part is the future prospects of the Wi-Fi technologies. We introduce the Wi-Fi 7 and the Wi-Fi 8 in this part. And the last part is the conclusion of our representation. The introduction part. The Wi-Fi 6, or it could call it IEEE 802.11ax technology, is an IEEE standard from the Wi-Fi Alliance. This is technologies for the wireless networks. The Wi-Fi 6 introduced groundbreaking physical layer protocols, such as the OFDMA technologies, the 1 kilo QAM technologies, and the BSS calorie technology. Use those technologies to address the spectrum congestion and in this question in the Wi-Fi 4 and Wi-Fi 5, and improve the power efficiencies to make the Wi-Fi 6 systems save more power than the Wi-Fi 4 and the Wi-Fi 5 system. Uh, Wi-Fi 6 could handle very high density wireless access in a high capacity wireless service environment, such as uh, a big party or office building. With this table, we could see that the Wi-Fi 4, the max speed is the 800 megabit per second. The Wi-Fi 5 is the 3.5 gigabit per second. The Wi-Fi 6 is 9.6 gigabit per second. The modulation technology, the Wi-Fi 4 max is the 64 QAM. The Wi-Fi 5 max is the 256 QAM. The Wi-Fi 6 could be 1 kilo QAM. It means that in each symbol in the Wi-Fi 4 max the information it could carry is 6 bits. The Wi-Fi 5 the max is the 8 bits. The Wi-Fi 6 is the 10 bits. The physical layer innovation in the Wi-Fi 4 is the multi-input, multi-output technologies. In the Wi-Fi 5, the MIMO technology could use for the multi-users, but it only could use when the download. In the upload, it can't use that. But in the Wi-Fi 6, the multi-input, multi-output technology for the multi-user could use both for the upload and download. And the Wi-Fi 6 introduced the OFDMA. This page is the OFDMA. OFDMA is a part of the physical layers innovations. You could see that in the picture in the traditional communications, such as the Wi-Fi 5, is the OFDM. We could see that the communication channels only could use a sense for a single user, each channel for one user. But in the Wi-Fi 6, the resource units could use for the multi-users, such as there has a 4 lanes of expressway in the Wi-Fi 5. Each line only could have one car, but in Wi-Fi 6, each line could use for the multi-car, like the blue car user 1 this time for this channel, and then in that time span, they then change it to the yellow car, and the blue car move to this channel, and then the next time the yellow car change to the red car, like the user 3, and the OFDMA technology could use to reduce the latency of the Wi-Fi 6. The latency is lower than the Wi-Fi 4 and Wi-Fi 5, and the OFDMA could use to enhance the spectrum utilization. And this page is for another physical layer innovation is the 1 kilo QAM. We could see that the Wi-Fi 4's 64 QAM technologies that the 16 points per quadrant. Each symbol represents 6 bits, and in the Wi-Fi 5 is the 256 QAM. Each symbol could represent 8 bits informations, and the Wi-Fi 6 is the 1 kilo QAM. Each point could represent 10 bits of the informations. Wi-Fi 5 uses 256 QAM quadrature amplitude modulation technology, and which only is very low. But the Wi-Fi 6, we could see that Wi-Fi 6 improved the information in each symbol 66.67% than the Wi-Fi 4. And this page is the BSS coloring technology, the basic service set coloring technologies. We could see that in the traditional Wi-Fi standards such as the Wi-Fi 4 and Wi-Fi 5, no BSS coloring technologies. They have sometimes have congestions because all the channels may be interrupt to each other. But with the BSS coloring in Wi-Fi 6, we could see that the black zone only interact with the black zone. The black zone don't interrupt the yellow zone and the green zone. So the Wi-Fi 6 could assign a 6-bit coloring ID to each basic service site, and devices could ignore the frames with the non-matching colors, so the other colors, other service site don't interrupt each others. So it could reducing the unnecessary processing of the Wi-Fi system and improve the speed of the Wi-Fi 6. In the Cisco, they had 4 years ago they had a test. The test result is that Wi-Fi 6 with the BSS coloring technology could increase the throughput capacity 40% more than the traditional Wi-Fi 5 in case of 50 AP office environment, and the packet collision rate reduced from Wi-Fi 5's 28% to Wi-Fi 6's 9%. And this page is for the Mac layer in innovation for the Wi-Fi 6. This is the target wake time. In the traditional Wi-Fi, such as the Wi-Fi 4 and Wi-Fi 5, like in that picture, the Wi-Fi card, this frame is the communication. The other 3 frames is the waiting. In fact, in the other 3 frames, that devices, the net card, Wi-Fi net card, doesn't need to work. But in the traditional, it needed to wait. When wait, it needs to consume power. But in Wi-Fi 6, like we see, this picture is provided by Huawei. This frame, communication, and other 3 frame, sleep. So the sleep could make the power saved. Only this frame need the power, and the other 3 frame don't need the battery power or the very low power. So that technology, target time, could enhance the mobile devices battery life to make the like in the maybe in the traditional Wi-Fi 4 and Wi-Fi 5 that a phone only could use 6 hours, but with the target wake time in the Wi-Fi environment, in the Wi-Fi 6 with Wi-Fi 6, that mobile phone maybe could use 7 hours to improve uh, the ability of the battery life. and that is also useful for the Internet of Things in the because some sensors need to Wi-Fi to communicate with the central control computer. So the enhancement of the target wake time bring to the battery life to maybe make this sensor. In the traditional, it need to change the battery every 3 months, but with the Wi-Fi 6 target wake time technology, that device is maybe every 5 months or 15 months to change the battery to make the it use smaller battery or maybe make it in the same battery set. Maybe it could use longer time. Yeah, this picture also show the target time how it work. And this page is for the multi-user, multi-input, multi-output technologies. The Wi-Fi 5 only download the link could use this multi-user, multi-input, multi-output. But in the Wi-Fi 6, it could the maximum the uh, expensive high-performance router could use 8 by 8 upload and download the multi-user, multi-output, multi-input, multi-output technologies. But it is only used for the most expensive routers. Some cheap routers may be reduced to the 4 by 4 or 2 by 2. And this picture will could show that the multi-user, multi-output, multi-input, multi-output how use. You could say the router gave two streams to the laptop computer because laptop computer need more speed of the internet and only one stream for the each mobile phone because the phone don't need the high speed of the Wi-Fi internet such as the laptop computer. The multi-user, multi-input, multi-output technology is mean that give the most demanded devices the most high speed, and give the not most demanded or the low demanded users low speed to maximize the efficiency of the same router's Wi-Fi resources. Um, and the social economic impacts. We could say that in that picture, this part is for this. We could say that in that picture, that was 6 years ago, the Apple's new phones, they are they are introducing this new Apple iPhone. You could say that this says the Wi-Fi 6 because in the iPhone 11 this series. But they're introducing the Wi-Fi 6 in the before than that, like iPhone X or iPhone 10, iPhone 8, they only could use Wi-Fi 5. So that it means that the Apple, the phone company, mobile phone company, they are they say the Wi-Fi 6, the Wi-Fi evolution is very important. And this picture shows that Wi-Fi 6 by the 1 kilo could have a much more around the 40% improvement of the speed than the Wi-Fi 5. In this, the Qualcomm's they are in the Qualcomm's maybe from the CES. This picture, this Qualcomm shows that the download to transmit a same document in the Wi-Fi 6. At the same time, it could finish the 59%, but with the traditional Wi-Fi 5, it only could finish 16%. So in that case, we could see that there are uh, two 200% much improvement of the Wi-Fi 6 transmitted speed than the Wi-Fi 5 for this Qualcomm's test. And this part is for the industry's applications of the Wi-Fi 6. And in the Qualcomm, 2 years ago, the Qualcomm tested. They have shown that the Wi-Fi 6 could make the 50 more plus devices environment. It could have this wireless internet with only 1 millisecond latency, and on the information energy efficiency, that's a TWT technology extends the smart sensor battery life from 6 months to 24 months, around all of 2 years, from half year to 2 years. That's a very big leap. And that picture shows that on the left shows that the smart home and the Singapore's HDB. Their official says that the Wi-Fi 6 could make the smarter homes in the Singapore and receiving around of the of the smart homes depart of the sensor. They could save 40% energy. Yeah, that could make Singapore more greener. And this picture is of the industrial IIoT transformation. Um, this picture is the DR6018 uh, inter internet card, net card, and we could see that the that card could have the smart APTWT technology. We could see that that card shows that the industrial um, the companies they think the Wi-Fi 6 is very important, so they need to uh, do some devices that are like this YPQ 6116010 to introduce the Wi-Fi 6 to the industrial Internet of Things. This could improve the industrial 4.0 evolution. And this picture is for the um, Wi-Fi Wi-Fi energy consumption versus the 5G mobile, yeah, energy consumption. We could see that the 5G mobile, the 5G mobile phones work on the 5G is consumes more energy than when they working in the Wi-Fi 6. So the Wi-Fi 6 is very important for the energy consumption control of the communication. If other users use the 5G is consumes a lot of energy. But then we could introduce some Wi-Fi 6. Not all the users use the 5G or 4G. Some users use the Wi-Fi. Use the Wi-Fi could save the energy, and we could see that the Wi-Fi works could make 150% more energy efficient per megabyte than the 5G. So Wi-Fi is very green than the 5G. In a report, they said in the 5 years later, in the 2030, is the year of 2030, the Europe's ICT sector's carbon emissions, the carbon dioxide emissions, could equal to 5 years ago, the 2020s, the Africa big country, the Congo's fossil fuel carbon dioxide emissions. So that it's very important to control the emissions of the communication systems. And this we could see that the home office VPN, cloud computing, and gaming and the media use a lot of have a lot of downstream and upstreams demanding. So when the this we could introduce in the Wi-Fi 6 to this part to kick out the Wi-Fi 4 and or Wi-Fi 5 system in this part, introducing the Wi-Fi 6 or even Wi-Fi 7, then could use make this part where this network more to consume smaller energy to make the Earth greener. Yeah, we could, and for the future prospect, we could see that the Wi-Fi 7, it could have the breakthrough, have the MLO multi-link operation, and the example is that the MLO technology could make the gaming latency drops from the Wi-Fi 6 20 milliseconds to only 5 milliseconds, and the Wi-Fi 7 introduced in the 4 kilo QAM technology. It could have 20% more through output per symbol than the 1 kilo QAM in the Wi-Fi 6. And the Wi-Fi 7, in fact, now is being introduced. You could not in the internet. You could buy some routers. Have the Wi-Fi 7 and the mobile phone, the new mobile phone, and the new laptop, the new desktop, new net card could also use the Wi-Fi 7. And in the future, in the several years ago, maybe 3 years later or 4 years later, the Wi-Fi 8 could be also be used. And the Wi-Fi 8, the key innovation is the terahertz spectrum technology. If we could see that the Wi-Fi 8 could get 10 times of the peak speed than the Wi-Fi 6. So the Wi-Fi technology is also in evolution in every year. The Wi-Fi 6 and the Wi-Fi 7 is not the end. In the future, there may be next decade, maybe there has a Wi-Fi 9. And that is our conclusion. The technological summaries of the physical layer innovations of the Wi-Fi 6 is the Alex such as OFDMA, 1 kQAM, and the Mac layer open innovation is the target webcam and the multi-user, multi-input, multi-output. And those the Mac layer optimizations make the Wi-Fi 6 be greener. The and the physical layer innovations make the Wi-Fi 6 could have the much more speed than the Wi-Fi 4 and the Wi-Fi 5. And the social value, we could see that in Delos 2024 report, the Wi-Fi 6 could make the enterprise, the companies, their ROI 65% higher, and the Wi-Fi 6 could make the every access point reduce the 2.1 tons of the carbon dioxide emission every year. So we could make a conclusion that the Wi-Fi 6 established the wireless foundation for the metaverse and the industrial 4.0. Oh, thank you for your hearing of our representation.